All right, cool. I've never had like such a big introduction with the music and stuff. It's quite nice. Feel a bit like a rock star. I'm going to talk about data binding. I started with the idea of doing a talk about it like half a year ago because there were some blog posts about the subject, but most of them were very basic. Like they focused on getting rid of find view by ID mostly. It's gotten a bit better by now, but still. And there's so much more to data binding, and I think it's easy to get started with most of it. So in this talk, I'll give some examples of using data binding in real-world projects, mention some caveats, how it works internally, because I think that's quite interesting as well, and some like tips and tricks, some advanced stuff. I have a few like different topics that I'll jump from like one to the other because I would need 2 or 3 hours to do like a really good talk about everything, but I just want to mention a couple of things that you can then, like I think today is Sunday, so tomorrow when you go back to work you can maybe start using and explore a bit further and figure out how they work. So, who has used data binding before? Okay, not that many people. That's okay, I'll go over the basics first. So, I guess when you're developing that, the most boring part really is like setting text and images in your views, right? Like you have to have a bunch of code that takes care of that. You have UI behavior like setting views visible or invisible, maybe enabling disabling, like all that code is kind of mingled into the rest of your code, which contains actual logic. It's easy to create bugs by forgetting to set a value, or you make copy-paste mistakes. We've all been there, I guess. And all of this, like this code that glues together the data and UI, it's kind of polluting the rest of the code. So data binding is, like, to put it in a very simple way, a way to connect data sources with views. That's like the simplest definition of data binding. And then with a bit of extra effort, you also get automatic updates. So when the data changes, your view is updated automatically as well. So that's very nice. And if you have a history in .NET, like with WPF or Windows Phone, then you have probably worked with MVVM and data binding before. Microsoft kind of came up with that concept of combining those two about a decade ago, I guess. And if you've worked on the web with Angular, then you're also very familiar with data binding. So why would you use data binding even, right? I think the first point on the slide is the most important one, cleaner code. Like who doesn't want clean code? I think that in itself is already reason enough to investigate data binding. But if that doesn't convince you, then you can also add simple expressions in your views. Like you can calculate margins on the fly, you can format strings in line. I'll show how that works during the talk. And you can create your own custom attributes, which is a very powerful aspect of data binding. And I'll explain that in full as well. So how do you get started? The first thing you need to do, there are 3 steps. The first thing you need to do is enable data binding in the Gradle file. So in the apps build.gradle file. So you add a data binding block inside of your Angel block and you set enable to true. Like it's disabled by default. The reason you need to do this in the build file is because the data binding framework hooks into the build process to generate code. So that's why. Second thing you need to do is update your layout. So the only thing that's really required is that you wrap your entire layout inside of a layout tag. So the layout tag becomes the root of the layout that uses data binding. As soon as you've done that, then like the compiler knows that this layout file is using data binding, and it will generate some code for you. If you really want to make use of data binding properly, then you also have some other tags. So the first one is the data tag, which is just a container for variables that are used in the layout file. And then you have the variable tag, which is used to define a variable, obviously. So you always have to specify the name and the type. So the name is something you choose yourself to refer to the variable inside of the expressions in the rest of the view. And the type is the full package name and the class name. And then to actually start using these variables inside of your layout file, you can then use data binding expressions. So a data binding expression you can recognize by like the ampersand curly brackets. People have started calling this the mustache operator because when you look at it sideways, it's kind of looks like a face with a mustache. So inside of the mustache operator, you define your expression. In this example here, it's just printing out the user's first name. So you refer to the variable that you've defined in the data block, and then you can just get the first name field. So user.firstName, it should either be a public field, or you can also use a getter. So if you have a private field and a public getter, then data binding will figure out, even when you just write user.firstName, that it needs to use the getter. So you don't need to explicitly state user.getFirstName. So that's nice. The third thing you need to do is change the way you set up your activities. So usually you would use setContentView, but you need to change that with data binding util.setContentView. So the data binding util class is a class that's available to you through the data binding framework. And then you just reference the activity and the ID of the view that you want to use, as you usually do. And this will initialize the layout. So as soon as you do this, your activity will work. The thing that this does, really, is it, there's a class generated for each layout file that has data binding. So each layout file that has a layout tag as the root, a class will be generated for that. And the naming convention for the binding classes is the name of the layout file, in canon case, plus a binding suffix in the end. So it's pretty straightforward. And this binding class contains references to the views. Like if you have views that have an ID, then you have a reference to those. And it has methods to set the variables that you define in the layout file. So for user, in the earlier example, we would have a setUser method. So the way you use that is by keeping a reference to the binding object that is returned by setContentView, and then you can do binding.setUser. So in our previous example, where we had the text view, here we would then just show George, because that's his first name, the user's first name. So it looks a little magical, but it's quite straightforward how it works actually. So the first thing, when you run the build process and data binding is enabled, the first thing that happens is that the layout files are processed. So it will strip out the data binding specifics in the layout file, like the layout tag, the data tag, and the variable tags, because Android can't parse those on the fly. And then it will start parsing the expressions that you made, and then it will generate Java code to replace all of the stuff you defined in XML. The nice thing about having this at build time is that you have compile time type resolution. So if you do anything wrong in your expressions, then you will get a build error rather than a runtime exception. That's very nice. Another advantage of having Java generated for you is that you can actually check out the code. So you can find the generated code in the build folder. So if you run into issues and you want to debug, or you're just curious to see how it works, then you can do that. It's very interesting. So the next thing that happens is all the views get found. Like the view hierarchy is only traversed once, which I think is also a big advantage compared to find view by ID, for example. Every time you do find view by ID, you go through the entire hierarchy until the view is found. With data binding, it goes through the entire hierarchy only once and keeps a reference to all of those views. And those are just public static fields inside of the binding class. So that's kind of how it works when you press build. So there are different ways to start using data binding in your projects. Like a way to get started is to replace find view by ID or butter knife, as a lot of people wrote about. That's nice. Of course, you can do a lot more, but it's slightly less verbose than butter knife. It's definitely less verbose than find view by ID, and you don't have all the casting. So it's perhaps a good way to introduce data binding to your project and kind of get used to it. So yeah, like in this case, you just have like a public static reference to username on the binding file. Username is text view, and you can just set the text so that it's a convenient way to get started. Then I took some examples that come from the documentation that I think are interesting to look at. This one here, it sets the text to an integer, so there's two integers that are added to each other, so you can do some math, and then you can use an actual Java class, string.value of. There's also an example in there setting a view visible depending on whether the user is an adult or not. It's very nice, it's powerful, but they shouldn't really do that. That's supposed to be an exclamation mark. I'm not sure why it's two question marks. It's supposed to be an exclamation mark because I think that it's kind of dangerous to put this kind of logic inside of your view. I think logic should be in your view model or your presenter or whatever you're using. Because when you put application logic inside the view, you kind of make it harder to test. You make it harder to understand. The logic might be in two different places, which is generally a bad idea. So I'm showing this example, and you can do it, but just because you can doesn't mean that you should. Just so you know. So this is, I think, a good example of how to use data binding. So we just have a simple profile screen with a profile image, the user's name, email, and location. And the way you can bind this data is just by, for the edit text, you just bind the text. So you have a view model that has a user, and that user has a name, email, and location. Very straightforward. For the image, we're doing something special. Add image URL is not attribute that's available out of the box. And I'll get back to that later, this specific example. What's good to know is that generated data binding code automatically checks for null, so you avoid null pointer exceptions. So in this example, if user would be null, then user.name would have its default value assigned. So for a string that's parentheses null, if you're referencing user.age, where age is an integer, then it would default to 0. So that's nice. But yeah, so the data here is static. I mentioned updates before. So profile screen, that's probably not going to update, but if you have a different screen with data that needs to be updated, for example, if you have a live scores app for football games, you don't want to have to refresh, reload the view every time. So if the data changes, we want the actual view to also be updated, right? And there are two ways to do that. So option one is to replace your fields types with observable field of T. There are also a few helper classes like observable boolean that you can use. And in that case, as soon as you do this, then it already automatically gets updated. So as soon as I change the first name in code with the setter, then the view gets updated automatically. So that's nice. It's fine to use a public final because it's safe, because you have a .set and a .get method on the observable field. And when you make it final, then it can be overridden. So the second option is a bit invasive in a different way. So you need to extend base observable. That's another way to do it. In that case, you can still use your fields like it usually would, so it's just a private string, last name, there's a getter and a setter, and then it's required to use bindable annotation on the getter, and then every time you change the value, so in the setter, for example, you need to call notify property changed and pass the ID of the property that is changed. So this says BR, gov last name. What is BR? So in Android you have like the resources class that gets generated, that's the R file. For binding you have a binding resources class. So that's kind of the same thing. So every property gets like its own ID there. So I just quickly, like it's not necessary to know how this works internally, but I think it's interesting to take a quick look because it's quite cool. So internally, the code that gets generated, there is a long that contains dirty flags. There's also a comment with the mapping so that you know which flag is which. And then when you change the user object, for example, then it will call update registration, it will change the actual user, and then it will say change the set the flag to dirty. And then it will do notify property changed, and it will call request rebind. So request rebind is an asynchronous method. That's important to know. I'll mention more about that later as well, why that is important. And eventually request rebind calls a method called execute bindings. And inside of execute bindings, you have like a whole list of if statements to check if the flag, like which flags are dirty. And here, like if the last name, user's last name flag is dirty, we will update the last name of the user. You can see here as well, there's a if user not as null, so that's the null safety checks that are put in place automatically for you. So that's nice. Another thing that's I think is important is two-way binding. So if you have a form and you want to deal with user input in edit text or a seek bar, for example, how do you set that up? So this is the standard one-way binding. For two-way binding, it looks like this. So if you can't see the difference, that's because there's only one character, and that's the equals sign. So instead of having ampersand curly bracket, it's ampersand equals curly bracket. That's the only thing you really have to do. And now if the user changes the text in the edit text, then the field on the model will also be updated. So that's really nice. This doesn't work for every attribute, but it works for pretty much all of the ones you care about, like edit text, checkbox and switch, number picker, seek bar, all of those. They have attributes that bind two ways. Of course, the referenced field, in this case, first name should either be public or have both a getter and a setter, because otherwise you can't update the values. And that's really all there is to it for two-way binding. So that's like very easy to set up. Only one character, but it can be a big time gain compared to what we did previously with like text watcher and stuff like that. If you want to see a good example of two-way binding, Eric Hellman has a repository on GitHub where he does two-way binding and form validation. I think it's called data binding form validation. When I upload slides later, I'll make sure the link is in here. It's very interesting. It's quite small, and the only thing it really does is does two-way binding, and then it validates the data and sets error states and stuff like that. So I think that's a very interesting example. Then custom attributes. This is kind of like the most powerful thing, I think, in data binding. So you can create your own attributes with binding adapters. So I showed the profile screen earlier, where I had an image URL attribute that I defined myself. So the way that you can do that is by creating a binding adapter. So the thing you need to do really is just have a public static method somewhere. The name of the method doesn't really matter to the framework. It should just make sense to yourself. The thing that matters is the binding adapter annotation. So What are the important parts here? The first one is, like, the first parameter to the method should specify the class that it applies to. So in this case, it only makes sense really to have an image URL on an image view. So here, this attribute will be available to image views. Then there are two more parameters, and those map directly to the parameters defined in the binding adapter. So the attribute name can be anything. So here I picked image URL and error because those kind of made sense to me. And those map directly to string URL and drawable error. And then it will kind of figure out the type automatically and also make it a bit easier for you in the view to define these things, which is nice. And then here I just use glide to load the image and show the error drawable if that is necessary. Just something you should know, if you define two parameters in your binding adapter, then you, by default, they're both required. So if you want to make them optional, then you need to add a flag that's require all and set that to false. So that's something you should keep in mind. Another good example of a custom attribute is changing the font on a text view. This is something that Lisa Ray came up with shortly after data binding was released, and it's really cool. Typically on Android, changing the font is kind of annoying. So you need to either subclass your views and set it in your custom class, or you need to use a library like calligraphy, which adds overhead to your app. So with data binding, this kind of makes it a bit easier. So we can just create a custom attribute app:font, and inside the binding adapter, the only thing we really need to do is set the typeface of the text view. This is a short example, like you also need to provide the font cache, obviously, but the slide is not big enough for that. But if you're interested in that, then you should check out Lisa Ray's repository. It's quite nice. So then when you want to set the font on the text view, all you need to do is add the attribute and pass a string to the name of the font, which then the font cache interprets and fetches it. All right. So when I talk about data binding, people often ask me about animations because they can see the use of data binding and they would like to start using it, but they can't really grasp like how do you still do animations? Because it seems like there's a lot of like behind the scenes magic going on. Like how do I influence that? But it is possible. This is one simple option. If you want to fade in view when you set it visible, or fade it out when you set it invisible, then you can create a custom attribute, animated visibility, for example. You can apply that to the view class, so it works for every view, and then take an integer for visibility. And then you can use object animator, like check the current visibility, set the visibility to the end state, figure out what the end state should be, and then just start the animation. So this can all be done in a binding adapter. This is just like one way of doing it. There's a few. I would recommend that you check out, like I added a URL to this slide as well. I would recommend that you check that out. It's the official Google developers blog on Medium. They explain two different ways of doing it there. And one might be more useful than the other based on the situation you're in. But it's possible, and it's quite easy. So another thing that's important is how can you handle events? So one way to go about it is just to define a OnClick Listener in your view model. You have view model in the examples a lot, but it could also be a presenter or whatever. It's up to you really. And then you can just reference that in the OnClick. It's not even necessary to use view.onClick Listener to deal with clicks, because the signature of the method just needs to be the same. So if you create a method that takes in a view parameter, and then that can handle the click. So you don't need to use the official view.onClick Listener. And this is possible because the data binding team took that into account when they built the platform or the framework, and it can be used for all of the event handlers, not just OnClick Listener. As long as the parameters match, the event handlers will work fine. So that's might be like a good step to cleaning up your code a bit as well. Then something I find annoying is like when you use text change listener, text watcher has 3 methods that you need to override, and usually I really only use one of those. So there's like 2 empty methods, seems quite useless. So instead of using standard text watcher, in data binding you can create helper methods to map attributes. And this specific one was added by the data binding team themselves to make things easier for us. It's very nice. So I can just use, or you can just use after text changed, and then you only need to implement that one method rather than having a text watcher with 3 methods. So that's cool. Another thing that's possible, and it's very nice with event handlers, is you can pass parameters. So if you really want to clean up your code, get rid of all the Android SDK references, then this is very useful. So you can just, like if in your view you have a variable called user that maps to the user class, you can pass that to a method on the view model as well. So for that you need to use a lambda expression inside of your view expression. So you have parentheses, arrow, user view model.save, and then you can actually pass the variable user. And then in that view model, then we just have a method save that takes in the user and then takes care of the saving. And I think this is really nice. This really allows you to keep your view model or your presenter or whatever as a pure Java class, which makes the code a lot cleaner, a lot easier to test. So that's a really good feature. And I want to talk a little bit about architecture. There are multiple ways to architect an app, and the Android team at Google, they say you can do whatever you want. The platform doesn't enforce anything. I think we can all agree that having all the code in the activity is not a good idea. And one of the more common patterns to structure code lately is Model View Presenter, MVP. Who has used that before? Not that many. Yeah, I quickly want to mention MVVM, Model View Model. Is there anyone who has used that before? No, even less than MVP. Okay. So MVVM, as I said before, I think it's something Microsoft first came up with. So you have the view as the entry point to your application. There's a one-to-many relationship between the view and the view model. So one view can make use of multiple view models. The view has a reference to the view model, obviously. The view model does not have a reference to the view, and the view does not know about the model. So if you compare MVVM and MVP, I think a presenter and a view model are very similar in a lot of ways. But I guess the biggest difference is that usually the presenter would have a reference to the view, whereas the view model is not explicitly aware of the view. So the view just calls getters, setters, and event handlers on the view model. And when you use data binding, then it kind of acts as the glue between the view and the view model. So you don't need to take care of any of that yourself. So a simple example is like a to-do app where you have view model tasks, And when that calls get tasks, then the view model sets like a variable is loading to true. That makes like through the data binding library that sets like a spinner visible on the view. When the view model gets the callback, then the spinner is set to invisible again, and the data is loaded automatically in the view. So that's very nice. Like MVVM and data binding really like go hand in hand. And like the view model in this case has the sole responsibility really to represent the data that is behind the view or part of the view. And like it depends on how you want to architecture your app, but like I personally prefer the view model to be a standard Java class, like I said earlier. This makes it easy to test. If you don't have any Android SDK references, then you can just write a unit test to test kind of what the state of your view should be based on the view model, which is very nice. But yeah, you can tune this as much as you like. Some people prefer to have the view model just for data and to have a separate class for the event handlers. You can also just have the event handlers inside. Like it really comes down to what you prefer. And then I want to mention some tips and tricks that I think are useful. So, first thing I want to mention is recycler view, because like how do you actually do this inside of like a view holder, inside of an adapter? How does that work? So the first thing you do when you create adapter is you create your own view holder. So in this example, I keep a reference to list item binding. This is a generated class based on a layout file called list_item. So it has generated the class list item binding according to the naming convention. When I create a view holder, I pass a reference to that and set that. You still need to call super with a view. But luckily you can get a reference to the view by calling binding.getRoot, so that's convenient. And then usually you would create a bind method where you can pass the object that needs to be bound. And just set that in the list item binding, set user. As soon as you do that, then the values will be updated in the view, right? You might notice there's a method called to execute pending bindings at the end of the bind method. So this forces the bindings to be processed immediately instead of being delayed until the next frame. So as I said before, it's asynchronous, but recycler view will actually measure the views inside of it immediately after calling onBind view holder. So if you have some timing issues, like if, for example, if you have a list item with 3 lines of text and a list item with 1 line of text, the measurement would be wrong if you don't trigger the binding before the measurement is done. So that's very important. If you use recycler view, make sure to call execute pending bindings. So then inside of the adapter, you have onBind view holder. The only thing you really need to do here is get your object and pass it to the bind method. And that's it. And then inside of your activity, like you have your binding reference. Binding.users in this case is like a reference to the recycler view inside of the view. Then you can set the layout manager as you usually would, and you can set the adapter. So that's really it. But you can go like beyond this. You can go a step further. If you set this up right, like you can make a generic binding adapter that takes a layout file, a list of objects, and does all the binding for you. And in that case, you really only need to define one adapter for your entire project. And you can just instantiate that with the correct layout file and a list of objects. So I'll show it very, very shortly, because of course there's a lot more to it. So you can create a binding adapter that creates an attribute called items. You apply that to the recycler view and take in a collection of T that has a reference to all the items. Then you create a binding recycler view adapter. This is a custom class that does all the magic, and you can just set the items there. So in this case, it becomes very easy to set this up for all of your recycler views. And then you can even add, you can add items, you can have a view binder, you can even add click listeners and long click listeners for the items inside of your list. I'm not going to go through the entire sample because it's too big and it doesn't really make sense, but the link is in the slide, which I'll share, so you don't need to be able to read the tiny letters up there. But it's really interesting to take a look at that, I think. Then a few more things. One, in the view expressions, the binding expressions, is that you can format strings, so that's very useful. So you don't need to do that in code either. So if you have a string call defined called greeting, where you take in a parameter, then if you use data binding, so you have the mustache operator, and then you just refer to the string as you usually would, but you kind of turn it into a method call. So you have greeting, parentheses, and then user.firstname, which comes from the user variable that you define. Then this will all automatically work. It's very nice. You can also do math in expressions, which is cool. So this is how you usually set padding, but you can also set the padding with binding. This doesn't really change anything, it does the same thing, but it just uses data binding. But then you can start doing stuff like this. So I often have padding double and padding triple defined in my dimensions. But when you use data binding, then you can just do math inside of your expression, which is really nice. It also supports adding the same or different resources. You can also subtract and divide. And you can do stuff like this. So if you have some kind of reference to whether this is a large screen or not, then you can change the padding depending on that. I wouldn't necessarily recommend that you do this because it's kind of weird. You should probably use the different resources for the different sizes, but it's a possibility. It's important to note that it is not possible to bind layout params attributes. So everything that has layout underscore prefix, you can't by default use data binding. So margin is one of those, which is kind of annoying. But luckily, it's possible to create your own binding adapters and override Android attributes. So this is an example with padding. So we're basically just creating our own implementation of Android layout underscore margin, completely overriding it, which is very powerful. So again, it's just a public static method. The name doesn't really matter to the framework, it just matters to yourself. Here, we want to apply this to all of the views, so that it's possible to set margin in all of the views. It takes in a float for margin, and then you just get the layout parameters, set the margin, and set the layout parameters again. So it's as simple as that. You can create your own binding adapters for margin, start, and top and bottom, and for any other Android attribute really. So it's quite nice. You can also reference other views as long as they have an ID. So in this example, I have a text view that I want to be visible only when the checkbox is enabled. So in the visibility of the username text view, I just check is the checkbox ticked or not, and set it visible based on that. And then as soon as you click it, the checkbox, then the visibility will be updated immediately. So that's nice. You can also like reference margin of another view, like you can reference anything really, as long as the other view has an ID. And then, like the last thing, I'm going to talk about binding conversions. So again, this is something like it's a public static method. The name doesn't really matter to the platform, it matters to yourself. The only thing that's important is that you have the annotation, the binding conversion annotation. And binding conversion takes in a parameter that is the type of the input, the type of the that needs to be converted, and then returns the type that it needs to be converted to. So in this case, I'm just creating a binding conversion from Boolean to visibility. Visibility is an integer, so it returns an int. And based on the value of the Boolean, I just return view.visible or view.gone. So this is like really nice. If you remember the bad example in the beginning I showed, where it did user.age smaller than 18, you don't need to do that because you have this, right, which is very powerful. So you can just set the visibility to user.isAdult, which is a Boolean, and then it gets converted to integer for visibility. The downside of this is that this is global for your entire project. So as soon as you create a binding conversion that goes from Boolean to int, then you kind of have used that one. There's no way to make a second binding conversion from Boolean to int. But this is really useful if you want to have your presenter view model really clean. And that was it. I wrote down a few resources that I think are very interesting. So the official documentation, if you haven't checked it, you really should. If you have, but it's been like a year, then you should check it again because they've updated it. It's really good now. There's a lot of examples. It has like a full explanation of how the binding expressions work inside of the layer file. I would highly recommend it. Then another one is George Mount's blog. I mean, some of the examples used in the talk are like based on his blog posts. They're really good. He started doing those about a year ago. He goes from like the very basics, like the find view by ID replacement, to more advanced stuff. Like he talks about recycler view as well. It's really, really good. He's one of the people working on the framework, so he knows what he's talking about. And another thing that's really interesting is Google I/O. Last year, there was a talk about advanced data binding, which was, again, with George Mount and with Iggy Boyard, who is also working on this project. So that's also really interesting. There they talk a bit more about the inner workings of it as well, like they go a bit deeper on that, which I think is interesting, but they also explain how to set it up and some things that you can do with it that you maybe didn't know yet. And that was it. Thanks for listening.